So the subject today is about glue-laminated design in advanced design. So I'll give you like kind of a quick introduction on what advanced design can do and how to use it. So I'll go ahead. So I've prepared a few slides first just to kind of show you some of like the dialog boxes and the options related to wood, and then I'll show you directly in the software how to use it. So the first important point is, what design code do we support? So in advanced design, it's an international software. We have Eurocode, Canadian code, and US code. So it will focus. Our focus today is so for wood design here in the US, we have the NDS 2018, and for Canada, it's the OAD6 2019. We also have the up-to-date code for the load combination, seismic, and so on. We included new libraries when we added this module. So as you can see on the left side, we have at the top the wood material for Canada, and at the bottom the glue-laminated wood material for United States. So those come for United States come from the supplement of the NDS 2018, and for the Canadian code, it's from the handbook. We also added new sections. So I'm showing here the glued-laminated sections. We also have, of course, sound lumber and SCL. We also group them into their own categories, so they're very easy to find. Another thing that is unique to it is the load duration. So in the load combination menu, you can specify the duration for your load combinations. If you're using the generator, so if you let the software build the combination list for you, the duration is automatically applied, so you don't need to do it manually. For the specific properties of each element, so in advanced design, we can design linear elements in wood, so beams and columns. So I'm showing you here just the top part of the design options. So we can specify things like the usage, the sharing case, if it's wet, dry, treated or not. We can specify all diameters so to reduce the effective section area. For US code, we have the temperature, but for Canadian code, it's not applicable to Canadian code. We also have some additional, bit more advanced option we can specify. So we can ask the software to check the deflection automatically for us. So either as a fixed maximum, so for example here it's 3 centimeters, or as a fraction of the length of the element. So it can either be a single element or a group of multiple elements, so the software will treat it as if it was one big element. We can check the bearing, so both at the extremities as well as in the inside the element. So if it's connected, I guess it would be a bit more clear when we have the software to show you. We can specify notches, and it also do the additional verification related to those. And for glue-lam, we have the also the extra check for the curved glue-lams. Okay, so now I'll jump straight to advanced design, just to show you a bit how it works. So to specify the code, it's right on the landing page. So we have the configuration menu. Also, if you're not English speaker, we have many different translations that you could use. And so right now I'm using the Canadian code, but after I'll show you with the US code just that you can see the calculation notes. But I would say the procedure and the workflow is exactly the same for both Canada and US codes. So I'll start a new project. I'm sorry for the small delay. Sometimes we have issues on our side since we're using a different build than what is publicly available.
While we're waiting, guys, if you want to answer the poll questions, they're right on the right-hand console. You can click on those. And also, while Etienne is presenting, you can drop any questions that you have in the live chat, and we'll visit them at the end during the Q&A.
Guess I'm really sorry about that. I'll just restart the software. Hopefully we don't lose too much time on this.
You're in good company here. Waleed's, I think he knows you. He says, hey.
Yeah, I recognize many names from the list of attendees. Okay, good. I'm very sorry about that. So for those who have never seen the software, so this is the interface from Advanced Design. We have the project browser on the left side. So this is where we'll see the list of all of the elements, so structural elements, but also other special types of elements like lines or the work plane we have here. So it allows us to organize the project. We'll have all of our loading and load combinations here also. On the right side, so we have the property panels. In the design, we don't use a dialog box to specify properties on elements. We use this panel here, so it saves a few clicks. And at the top is all of the tools organized in ribbons, and we can also add extra toolbars. But I won't need this one for today. So the tools that we use the most often during modeling is everything that we have on the Home tab, but there's a couple of more advanced tools in objects and utilities, so like generators and different tools to modify a structure. And so to show you with design modules, so I'll keep the structure very simple so we don't spend too much time modeling. I'll just create a short 2D frame right here so I can draw the elements directly on the grid. For support, so in Advanced Design, the supports, it's not like a node that you modify or anything like that. It's an element that you can place anywhere on the model. So I'll place it here at the bottom of the frame. So I'll snap it on the columns. Then if we want to modify the properties of those two elements, I'll select all of them and I'll go to the property panel. So we don't need everything. So I'll close the panels that we don't need so that it's a bit easier for you to focus on the important part. So first, the material. Currently, it's a concrete material. If you want to change it to wood, so if we had already included the wood material on our project, it would be listed here. If not, we can access the library directly by clicking on material. And this will give it access to the full library. So we can see the list here. We could also access the library. So they're sorted by category. So I'll start here with timber CA. And I'll select the glue-laminated category. So if I want to, for example, use the SPF 20FEX, I will import it. And in the list, so now it will be in the quick access list. And if I select it, when I close the dialog box, it will automatically apply it to the members. So as you can see, I have the GLT material. For the section, I could use parent check section, or I could once again access the library and pick one that was created for us. So we have a category for North America timber profiles, so they're very easy to access. And what I want is a GL section, and I'll pick here the 175 by 418. And when I click on OK, it will apply it to the model. If you wanted to have pinned connections at the bottom, so I could do it either by modifying the support or by adding a pin on the element itself. So if I wanted to release the moment in the strong axis, I would go to releases, total releases, And then for both extremities, I can specify which degree of freedom I want to release. For the moment in the tri-axis, that would be the RY rotation. And we can also display it on the screen if we activate these symbols. And maybe not for this top one here. And just a small detail. Okay, so now the bottom is fixed and the bottom is pinned, and the top is fixed. Okay, I'll save the project before continuing. Okay, so now we got the basic geometry. We'll need loading and load combinations. So I go to loading. I can create multiple load cases at the same time. I will include one load case for dead load, one for live load. So the first load case with the type dead load will automatically include the self-weight of the structure. So if I click on the dead load case, I can see here there's a gravity field and it's selected on all. That means it's applied to the entire model. If I wanted to add additional dead load, there are two ways I could do it. So the first one would be to go to load and then linear load, and I can trace it anywhere on the model. So in Advanced Design, the loading is completely independent from the structural elements, so you can draw it anywhere. It's not like assigned to a specific one. So it has a few advantages. So it allows you, for example, to have like one load that covers multiple elements without instead of having to specify multiple individual loading. For live load, so there's the second method you could use to apply loading, which is the one I personally prefer, is to right-click on the element and then use the load on selection. So it works with one or multiple elements, and it just creates a load that will cover the entirety of the element selected. Okay, so and the load will be listed here. So if you want to modify them, it's very easy to select them. And we also have our structural elements here. For the load combinations, so if I double click on combinations, I can use the generator and generate the list that I need. The critical one will most likely be this one here, the 102 with 1.5 times the live load. What's important with the load combinations is that if you create your own load combinations, you have to include them for each material that you want to design. So if I go to timber, as you can see, there is a list for which one are going to be used to verify the deflection and which one will be used to verify the resistance of the profiles. We also have the load duration that is very important. And as you can see, the case with the combination with only dead load is permanent or long-term, and the other two with live loads are normal or medium-term. Okay, so now if you want to look at the settings for the design, so it's at the bottom of the property panel. So we don't look at all of them right now. We'll come back after, but if we start with just some of the basics, so this is where we would specify if we have a load sharing case, if the environment is wet, dry, we can also specify if it's treated or not. If we have built up sections, so we also have a setting here for this. We have the hole diameter, which it's different than specifying a notch. So this will affect the area of the section, but there's not going to be the extra check for notches. And you just have to be careful about the units here. It's meters, not millimeters. And we have the temperature. And as I mentioned earlier, this is only for US code. So with Canadian code, whatever value I put, it won't make a difference on the design results. Okay, so before showing you the more advanced option, I'll just show you quickly the results and the workflow. So when I launch the analysis, I'll activate first the final element calculation to get the forces, and then I can also select which material I want to design. So here I will choose timber design. If I were to actually forget to do it, it's not a problem because you can always add it after. So when I'm in results mode here, I could go here and ask the software to do the timber design calculation. As you can see, we have this new group that popped up in the middle. It says timber design results. So this is where we'll be able to check the results graphically. So the first thing I normally do is look at the max work ratio, just to have an idea of what's going on here. So you can see it goes up to 75%. If you want to be in more detail, we could split it between strength and deflection. Here I suspect it's mostly strength and not deflection. So we have up to 75% strength and deflection. So there was some default values. So that's why we get the results even if I didn't define it. So we have 50%. There's a lot more things we could display graphically. So for example, we have not all, but many of the K coefficients. So for those who are from the US, so this is the equivalent of the C coefficient. So there's one like for temperature, for if it's treated or not, and so on. Here, since I kept the default value, it's probably all going to be 1.0. In case I just want to show that you can display them graphically. There's other things like, for example, to check the buckling length, the lateral buckling lengths, and so on. But I think what is more important here is the calculation node. So here we have a work ratio of 75%, but how did AD arrive at that number? So we can see it with the shape sheet. So this is where we have all of the details. So first we have the properties of the element and also the material at the bottom. In the center, we have all of the K values. So if you try, for example, to replicate an example that you have and your NCalc doesn't have the exact same results as AD, so the first thing to look for is which of the K value is different than your NCalc. We have the verification done for deflection. So right now it's testing. So it says that the worst load combination was the 106, the place with the largest deformation was the mesh 2.6. We have the deformation specified as a fraction of the length and then as a percentage. And then for strength, so the content here will depend on what type of element, but also the internal forces. So if there is no weak axis bending, you're not going to get the necessarily weak axis bending, for example. And so here we have the shear and torsion. We have the axial and bending. This one is a pretty big formula, but you can see exactly which values were used to arrive at the 35%. And we have the bearing here. So once again, I've not defined it, but there were some default values, so it's still giving me some results. If we want to have it like in a more condensed format, something that's a bit easier to print, we have the detailed report. So, oops, I guess there's a small issue here, but it's exactly the same information. It's just in one big table instead of being a dialog box with multiple tabs. Okay, and so now if we look at some of the options, more advanced options that we have for the design, so you don't actually need to go back to the model view to make those changes. So I can do them straight from the results view, because in advanced design, we don't lose the calculation results when we make changes to our geometry. We always have access to the old results, and we can directly modify the structure right here. So for example, for deflection, so if I wanted to change the limit, so right now it's using the deflection limit number 2, so it's L over 300, and there's a fixed maximum of 3 centimeters. So maybe I could increase this value so it doesn't cause any issues. And if we wanted, let's say, to check for L over, let's say 200, could change it like this. And so now if we rerun the analysis, we have the L over 200 here. And so I was able here to launch only the I can launch only timber design. I don't need to rerun the full analysis because those settings here, they don't affect the finite element results. So I can keep the old internal forces with no issues. So this is a bit faster. Then we have options for lateral torsional buckling. So here it was turned off by default. So as if there was like a flooring or something that was preventing it from having lateral torsional buckling. If I want to activate it, I can activate it for top, a bit wider here. So we have top and bottom. And for both of them, we have a drop-down menu to indicate how we want to support them. So by default, it's fully braced. We could also use braced at bearing points, fully unbraced, or user-defined length. So if, let's say, they were joists or something that was protecting it against LTB at specific locations, I could enter the spacing here of those joists. For example, 2 meters, and then it would use an unsupported length of 2 meters. I'll keep it at braced at bearing point. Then for bearing, so here we have 6 options. So we have at the start, the end, and the internal bearing length. So the reason why we have all 3 of those options is because in advanced design, we have a mesh engine. So it would be possible to connect an element like this without splitting the horizontal one. So the internal bearing would be used for this connection here, and the start would be this one. We can look at the local axis to make sure which one is start and end. So this is the start, and this is the end. I'll go back to this model. Okay, so back where I was. So if I leave it at 0, the software will try to automatically decide on a value, which means it could be useful for the width, because if the width is the full width of the member, I can just leave it at 0. If it was a different width, like if there was some sort of bracket or connection, I could specify a different value. But if it's just the same width as the member, in this case 175 millimeters, I can just leave it at 0. And here I'll put the length, for example, 0.15 for the start, and I'll put a different value like 0.2 for the end, and I'll leave the width at 0, so it will be automatically calculated. And so now we have our results here with it's only in this table, it's only displaying like the most critical one, which has a work ratio of 41%. If we want to see both sides, we could do it graphically. If I go to work resistance ratio, we can see specifically the ratio for shear, axial moment, and also for bearing. And I have slightly different values because it's not the same length on both sides. And then we have the options for curved glue lams. So you can look at the diagram either in the code or the handbook. I forgot which one it is, but yeah, there's a diagram you have to follow for this. And this will check. This will do the extra check for the delamination in the center of the glue lam. So the member on your model, like, it doesn't have to be curved. Like the check will be done, whether it's a straight segment or if you try to create an arch. In both cases, you can use that feature. Okay, now if we look quickly at the US code, so I will save this project. Maybe I'll save it with a name I can recognize a bit more easily. So I'll close the model and I'll change in the configuration menu the code to the NDS 2018. And I'll open my model back. So I don't have to like redo the model or anything like that. It is possible to change code on a project. In terms of the user interface and the modeling, there's actually no changes. It's all of the same options that are visible whether you're using Canadian or United States code. I think I would say the main difference is probably the temperature that is only effective for US code and not Canadian code. So if we relaunch the analysis with temper design, so one of the changes is that if you look at the coefficients here, instead of being K, it's C. So for example, CD, CT. So I guess in this case, most of them are 1.0. But yeah, so this makes it very easy to validate the model graphically. And then in terms of calculation nodes, so it's kind of the same principle. We have all of our material properties. We have all of the members properties, all of the C values. Then we have the deflection check and the strength verifications. So there are different formulas, but they're presented in the same way as the Canadian code. Okay, so this is all I had to show you today. If you have any question, you can put them in chat and we can look at them right now. So I believe there's a couple already.
Yep. So David said, can model be printed out to scale frame member sizes?
I'm not sure what he means by scale frame member size, but you could export it to many different formats, and I believe like if you use the IFC format, you should be able to like import it in a CAD software fairly easily. We also have DXF exports.
All right, David, let us know if that answered your question there. And then he also asked, can it be entered into a BIM or a quantity estimate takeoff of design?
Yeah, so well, it would depend on what format your other software supports. Most likely it's going to be IFC. But if you were working, for example, with Revit, you could be using our Power Pack, which would give you a better transfer. But we do have many different ways you can transfer it to different software. And for quantity takeoff, it's also possible to do it straight in Advanced Design. So it's actually a fairly popular question. So let me just show you if I go back to results. So we have the report generator. And in the report generator, it's a fairly sophisticated one, so you can do a very complex report, but most people would use it mostly just to get quick tables. And we have the bill of quantities that we can generate. So this will give you the quantity. So for each material, then for each sections. So it gives like the area, perimeter, length, volume, surface, weight. So depending on what are your needs, you should be able to, you should have all the information that you need. And then we have per cross section, then per length, because not all of the GL 175 by 418 have this the same length. So you get to see how many of each length you have on your model. And we also have a new module for cost estimation and CO2 calculation. So instead of taking those quantity and then putting them, for example, in Excel and then multiplying them by the cost, so you could do this directly in Advanced Design. So by default, it's going to be assigned to the material, but you could specify like per element a template for the unit cost. So you can specify a cost per weight, per volume, per area for plan element, and per reinforcement for concrete design.
All right. And David said, yes, dropping model into a CAD design at scale. Okay. And then we have another question. Are we able to create beam as flushed option and get some idea for which hangers to be used?
Not 100% sure what it means, but in Advanced Design, so the members, as you can see, like it will be like connected like from one center line to another. Like there could be ways to shorten the member so that it starts like right at the face of the column. For example, it takes a bit more time to model, but it is possible to do it with a rigid link. And then if you wanted to get your forces, so you could get them either graphically or in the results table to see like what size bracket you need. But honestly, I'm not 100% sure what he's asking.
Okay. Yeah. Depine, if you wanted to elaborate even more on the question, just throw it in the chat for us. And if it's something that we need to go back and look for, we can totally do that as well.
Yeah, and David mentioned, dropping model into a CAD design scale. Yeah, so if you export it with one of the export tools, the model is at scale in three dimension. So DXF is kind of like the easiest one to import because you can import a DXF in pretty much anything, but the DXF is just lines. Whereas if you export AIFC, it's going to be like a section. I mean, a starting point, end point, and a like section property. So there's a bit more intelligence there, but you cannot import them into every software. So, but most of the popular CAD tool, you should be able to find a plugin, or you should be able to find a procedure to convert the IFC to to 3D solids and to convert them.
All right. He said, I meant if beam is supporting floor joints or joists, can design the connection between beam and floor wood joists.
Well, we don't have connection modules, at least not for now, for wood. The only connection that we could design is for Eurocode for steel connections. So yeah, you would have to do it manually.
Alrighty. And I'm going to drop too in the chat box. If you guys think of any questions after the webinar, you can shoot me over an email and get you connected with the right person and the right answers. David said, can it be put into any 3D models?
Well, maybe I can just show him what it looks like when you export it, because it will be really dependent on your 3D software, software, like what is it able to import, what format does it support. Like for example, if it was Revit, it would work really, really well, but depending on what software you use, it would depend. So if I were to export it to DXF, for example, so I'll save it. So we could decide to export only the axis. So this would be useful, for example, if you wanted to transfer it to like a different, for example, design or Phantom software that doesn't support import exports. You could at least have a starting point with the center lines, or you can export the axis and cross section. So this will give you more of the 3D volume. And then if I go to AutoCAD, I just have to browse to the correct folder. and select. So if I use DXF, so this is like the like simplest import. Like this is the one that should work on pretty much any software, but the disadvantages is that all you get are lines. If you want like a more lines and like you don't get like a real volume or solids. If you want to have those, I said you need to use like the IFC format. So I'm using right now Advanced Steel. So this is a software that is able to import IFC format or many other BIM formats. So with Advanced Steel, for example, I would do it would be with the SMLX format, which is typically is the best one, or as I said, just the IFC. Typically, it works pretty well. So you would export the IFC, and then you would have to import it into your software. So if I go to a new file, this would be import export, import IFC. And yeah, so Advanced Steel is for steel structures, so it doesn't have the members. But if I did import a library with the Glue-Laminated, or if I were to build my own library, or maybe like convert it from the one in Advanced Design, it would automatically assign the correct member, and then I would have my full 3D structure. But it would be more than just a just like a solid. So now I just assign a random steel one, but as you can see, like it really transferred as like a structural element, not just a solid. But in Advanced, I would say generally like the best transfers would be with Revit. Advanced Steel works really, really well, especially for steel structure. For wood, Advanced Steel doesn't have the libraries yet for it. In a case of yes, it would really depend on your software. Can you insert the hinge in the beam? Yeah, so if you cannot insert like inside a continuous element, but what you could do is you could split it in two. You do it with the subdivide, or there's like more than one way to do it. But if I were to split the element in two, then I can put the hinge on either one of them or both. It would work too. So it would be with the releases. This is extremity one, so you can look at the local axis displayed on it to see which one is which. And for the moment on the strong axis, that would be RY. And so now it would behave with the hinge.